Hello and welcome to day 3 of Microsoft Connect. Thank you for connecting with me for this live training today that we're going through. This is Bring Your App to the Cloud with Azure Functions. My name is Jeremy Lickness. I'm a cloud developer advocate with Microsoft. I've got some exciting things to share with you today. I've been a professional dev for over 20 years. What's important here is to note my contact information. I've got a link to my blog and my Twitter. Twitter is the best way to get in touch with me. I do encourage you to ask questions throughout this. We have a lot of content to cover, but I will be jumping into those questions as we have time. If we don't get to your questions, feel free to direct message me on Twitter. I have open direct messages, happy to get in touch. What we're going to talk about today is really this evolution of taking an application from the left side, which is on premises, over to the right side, which is in the cloud. And in the cloud, we've got infrastructure as a service, which is your virtual machine experience. We've got platform as a service, and we've got serverless. And I would argue that the farther we get to the right side, the closer we are to a true cloud-native application experience. Before I get into how we're going to do this, though, I want to spend a little bit of time talking about why we would even do this. So anyone who's worked with on-premise applications knows that there's dozens of questions that you have to answer. You have to worry about things like physical access to your machines, things like how it's locked down, how you back up servers, do you take the tapes off site? So there's a lot of overhead that goes into this. Fortunately, for some time now, we've had this concept of infrastructure as a service. This takes a lot of those questions out of the equation. I would argue it does two fundamental things for us. First, it allows us to manage that virtual environment in a consistent way, but second, it paves the path to the cloud. In fact, lifting and shifting applications typically happens through moving virtual machines into a cloud-based environment. But we still have a lot of overhead in that scenario. We have to worry about the operating system, patching, security, taking care of all those items. That's why I love platform as a service. This is a concept that takes all the underlying nuances of the platform away from your responsibility. In other words, if you want to run a SQL database, you don't have to worry about installing the operating system, installing the database. You just worry about what you're using that database for. The same thing for a web application or an API application. So really you're just focused on how do you scale that platform. And then finally, what I would argue is almost the ultimate realization of the cloud is what we call serverless. I like to flip that around and refer to it as less server. This really abstracts your servers away from the process. We call it event-driven because the concept, if you've heard of microservices, is that you have a component that's triggered by something. That could be a queue, it could be a timer, it could be an HTTP connection request, but these events queue the code that runs. And then we can instantly scale that code because it's in a paradigm and infrastructure that's easily scalable. Arguably, one of the bigger benefits of this serverless is the concept of micro-billing. So we go from paying for the cost of hosting an entire virtual machine or even a platform that's up and running for endpoints and start to pay just for the use of that specific component or function. This is very powerful because I may have 100 APIs and I may have one API that's called 1,000,000 times and 99 APIs that are called a dozen times, and now I can scale those differently in serverless. Of course, we still play well with DevOps and provide that productivity experience of being able to get from the developer's machine out to the cloud in an automated fashion. Ultimately, this allows developers to focus on business logic, which is what they signed up for, and is a faster time to market. In the Azure platform, we have several serverless components. Two of the key ones are functions, which I look at as the code that you write to manage your application. And we also have logic apps, which are a way of stitching together various services, even services that aren't on the Azure platform. For example, you can plug into Twitter, you can plug into Power BI dashboards, connect into third-party services. So this is a powerful platform that sits on top of services like data, storage, memory, gateway connectors, intelligence, and bots. And of course, all of this comes with a very smooth development experience. This is integrated into your Visual Studio. You can do live debugging, you can troubleshoot, look at logs, and have all these areas of availability and functionality. Now today, I'm not going to focus on logic apps, and I'm really just going to focus on the data storage side of the story to keep things simple. Everything you see on your screen right now is something we'll touch upon in the demo that I'm about to show you. So for the first step, I want to show you how you can take that on-premise application, lift it to the cloud without having to deal with virtual machines at all. We're going to use platform as a service. The application that I have is a simple to-do list application. This is written with .NET Core 2.0. We've got a single page application, which is .NET Core SPA application. It's using Angular to serve the front end. That talks to a web API, which is also a .NET Core web API, which then uses Entity Framework to connect to a SQL Server database. This is running on SQL Server Express, and this application knows nothing about the cloud at this point in time. What we're going to do is take these components and lift them to the cloud by taking the web app and the API and moving them into what we call an app service. We're going to take SQL and migrate that into Azure SQL. So the steps to do that, we're going to start with a resource group. This is just a logical container in Azure of related assets. A resource group, you can destroy an entire resource group. You can script the creation of a resource group. You can even track billing by a resource group. So it's a logical container. We're going to follow the steps at aks-migrate SQL. This will tell you how to get your on-premise SQL up to the cloud in a straightforward fashion. We're going to make sure our application supports environment variables, which is how we'll manage secrets in the cloud. And then we're going to update the connection string once we move that application so it's talking to our Azure SQL instance. Then we're going to take the web app, make sure it's talking to the cloud version of the API, and move that into the cloud as well. And we're going to do all this live. I went ahead and migrated the SQL database so you don't have to wait for that process to take place. Essentially, there's a data migration assistant tool that you can tap into. With that tool, you point to your local database, you point to your cloud-based database, you specify which tables you want to move. This is going to generate a script that'll synchronize those schemas for you. Finally, you tell it to migrate the data items, and then it migrates that up into the cloud, and I've taken that step for you. So let's take a look at our application and move it into the cloud. First thing I'm going to do is jump into SQL Server Management Studio. So you can see I've got an instance that's connected to my cloud and an instance that's connected to my local SQL Server. I've got the application running. And in the application, we essentially have a list of to-do list items. Now, one of the things I'm going to do is say, "Hi, Mom." Say hi to Mom. That was one of my tasks. Let's go ahead and mark that complete and delete that. And so what we'll see if we go into our database, if I refresh this locally, you're going to see there's no say hi to Mom entry in this list. But if we go out to the cloud, it's still there because it's a separate database that I've already migrated. If we take a look at the application itself, you're going to see two .NET Core applications. The first one is an API application. And when I open this controller, it should look pretty familiar to anyone who's worked with .NET API, whether it's .NET Framework or .NET Core, it looks very similar. We've got a get operation that gets the full list of to-do items. We've got a get by ID to get a specific item. We'll also have create, update, and delete, so we have that. The other important thing to note is in our startup, I've configured this to look at app settings first, and then a higher priority than app settings, because I configured it last, is environment variables. So what will happen is if that environment variable is set, it's going to use that for the connection string. Otherwise, it'll take what's in my app settings, which is a simple local connection to my local SQL Server instance. That's what we have. So what I'm going to do is right-click on this API, go into Publish, and I'm going to create a new profile. We're going to create a new Azure App Service and click Publish, and this will open a dialog that gives me some options. I need a globally unique name for this to-do API, so hopefully connect-to-do API is available. We'll let that spin and select that. It's actually pulling down my subscriptions right now to make sure I've got the correct list of those. And then we're going to pick a resource group. Now I've already loaded a connect group. So we'll select that group. And then for the sake of this demo, we can pick a size for the server. I'm just going to go with the free server here. So we'll click OK with that. Make sure everything looks good. Connect to do API, resource group, app service plan, and we'll click Create. Now what's happening right now is basically two steps. The first step is it's creating a set of resources for Azure. These are templates for the app service, and there's two parts to the app service. There's the piece that's hosted as a platform that you can actually connect to as an API in the cloud, and then there's a plan that backs it that specifies the size of the servers that we're going to use and also ties into billing. What it's done is it's created those assets in the portal. Now it's going to build my application locally and publish those files out to the application. Once it's done, it recognizes that this is a web application, so it'll automatically open the website for me. So again, two steps: creating the target for it to publish to, and then loading the files. Now, there is one thing I want to point out. My good friends over in the League of Extraordinary DevOps talk about friends don't let friends right-click publish to the web. We're doing a developer experience right now, which is basically setting up our environment so that it's working. Once we have that working and up and running, we can always go back and plug in a continuous integration and a continuous delivery pipeline. So I'm not ignoring that. I'm just showing you the easy path for the sake of the demo. Now this did not connect right away, and that's because we have an API endpoint. So I'm going to API to do to get my list of items. Now while it's spinning up, I'm actually expecting that to fail, and here's why. When I launch that application, it still has the local settings pointing to my local database that doesn't exist in the cloud. So what I need to do is I need to go into my database and go into my connection strings and pull out a connection string that I can configure in the environment. So I'm going to copy that. Then we're going to come back out to the API that was just created. That's this connect to do API. And it's as simple as going into application settings right here. I'm going to pull that up. And then there's going to be a connection string section that we can paste that connection string into. So we'll scroll down, and here we have connection strings right here. So I'm going to type to do context. That's the name I referenced as it in the project. I'm going to paste it in. Now Azure was kind enough not to expose my username and password in this connection string. So I'm going to go ahead and type in these super secret values. So we'll go to the username, and we'll go to the password piece here. Enter that, and we're going to save that. Now if we come back out here, as expected, I got a 500 error because it wasn't able to connect to the database. But now that we have our application settings updated in this application, I'm going to refresh that request. And it'll take just a second to spin up. On the free plan, I don't have preloaded servers. That's definitely an option that I can take. So when I make that request or when it restarts, it has to spin up the server first. So that takes a little bit of time. But we'll refresh this, and we should see the spinner go out and pull. And now we can see we have a list of to-do items. The details don't really matter, but I am going to drill into a single item just to show that the full capability is there. So we've successfully moved our SQL Server and our API to the cloud. Now I just need to take one more step. This is going into the web application and changing where it's pointing to the API and updating that to our cloud-based API. Now in a larger application, we'd probably have a build process that would have different environments and stage these out. Again, I'm keeping this simple for the sake of the demo. Now I'm going to go ahead and right-click Publish here to set up the assets for the website. We pushed out the API, now we need to push out the website. The reason why I'm going to create a new app service for this is because typically your web app may scale differently than your API. The web app is essentially serving static resources, but the API is doing all the work of connecting to the database, so you may want different options to scale those. Again, we give this a name. We'll call this To Do Web. It's going to check and make sure it's a unique name. We'll move it to our resource group of Connect Group. And again, I'm just going to go with the free plan for the sake of this demo. We'll click OK. Make sure all of that looks good and go into create. Now this is going to go through a similar process. It's building out those Azure templates, pushing those out to Azure so I have a target for the website, and then it's going to build. One thing I want to point out with the build for this was created using a .NET Core MVC template with Angular. So it's Angular enabled, and one cool feature of Visual Studio 2017 is that it has full integration with a Node.js pipeline. So without me doing anything else locally on my machine, what this build process is going to do is take the Angular build process, which runs on Node, and takes all the different what's called TypeScript files and compiles them to JavaScript and optimizes those. It'll run that build locally. We can see actually if we watch the build process, we'll see it does an npm install to install related packages. It'll pass it through Webpack. So it's going to create a set of assets that it then hands off to the .NET Core MVC application so that it can host that web app front end. That's what's happening with this build process, and I'm going to let it spin through. If you have any questions, now's a good time to ask them, because I'll have a little bit of time before this deploys. Otherwise, I'll walk you through some of the gist of the deployment. So right now, I think I'm covering the topic pretty well. I haven't seen questions come in. That's great. We've got npm install, and again, if I don't get to your questions before the end of this, feel free to direct message me or contact me with one of the methods I'll show you, and I'll post that at the end of this live training. We've got npm install running right now, which anyone who's run that knows it's got to go out and find a million packages. I've run this build process before, so hopefully this will run a little bit faster than normal, but we are doing everything live. I wanted to make sure you saw start to finish just what this process looks like. And again, taking a web application that knew nothing about Azure or the cloud, building it to hook it into the web API, which we just migrated, and pushing it out. And once it does that, we're actually in the Webpack step now, which takes the JavaScript and optimizes it. So it's pulling out methods that may not be called, it's shortening the size of this, and it's creating an optimal package for delivery. We are pushing the build, we're still going. I'm going to wind this up with the cursor a little bit more. Everyone knows this trick to speed it up. Come on, build process. I promise you this happened faster in the hotel room, but that's okay. Again, don't hesitate to ask questions. Happy to answer them. We actually moved past the local Angular build process. Now it's pushing those files out. You can see it's adding directories. This is on the Azure site, and it's launched the website. So it'll take a minute to spin up for the first time. That's that cold start I talked about. But eventually we should get this to-do list. And notice that this to-do list is different than the local one. Actually, that refreshed because I updated the URL. But this has the say hi to mom. So let's go ahead and click this, do delete. We'll click OK to destroy the task forever. It sounds very final. And then on our Azure version of the database, we'll execute that, and we can see that that entry is now gone. Let's go ahead and tick off that we've migrated the API to Azure, and we've migrated the website to Azure. So we've just lifted and shifted the application. The next step that I want to take, however, is to talk about refactoring to functions. Now this may be a little bit of overkill for a to-do application, but imagine this is a line of business application that could have hundreds or even thousands of API endpoints. There's two challenges with that. You probably want to move to a microservices paradigm so that you can independently iterate those endpoints, both from a consumption basis and from an update and design basis. You may even have different teams working on endpoints, but probably you don't have the luxury of lifting and shifting your entire legacy app. In other words, you can't migrate it completely. You might have to do a piecemeal step. I want to show you what I believe is a good strategy for making that happen. What we're going to do is start with what we've already lifted into Azure, which is the front-end web app, the web API, and the SQL Azure. And then we're going to take this, add a little bit of room for a new method, and we're going to create a post function. This will be a serverless API that the sole focus is to insert a new to-do item in the list. In front of that, we're going to stand up a proxy. This is functionality that went to general availability this week. It was announced at Connect. And what a proxy enables us to do is take that legacy web app, have it point to the same APIs it's used to, but then we take over and proxy them wherever we want them to go. So we're able, for example, to say that all requests go to the existing web API application except the new post request that we're sending off to our to-do function. So the way we're going to do that, first we're going to work on the function. From the function, we're going to add a function app to the project, set up connection strings, build out the post and test it. Then I'm going to create this in the portal and deploy it to the portal. So let's see what that looks like. In Visual Studio, I'm going to right click on the solution, go into Add, New Project. And because I work with Azure Functions so much, it's actually defaulting on Azure Functions for me, and I'm going to call this To-Do Func App. It's a very creative name, and what this is doing is creating a host project. Now what you're seeing is a new dialog that was just released this week that allows me to pick between Functions V1, which use the .NET Framework, and Functions V2, which use .NET Standard. .NET Standard is nice because I can use ASP.NET Core. Since that's what the rest of my projects are, I want to go ahead and go with .NET Standard. We're going to do an HTTP trigger. I don't need storage emulation. I'm going to make this anonymous for now to keep the demo simple. So we'll click OK, and this is going to stub out a function project. That's a host for function endpoints, and these can be HTTP, Q, and other types of endpoints. Now that we've got this created, we'll get some red squigglies for a second while it loads dependencies. I want to rename this cryptically named function 1 to something more meaningful. We'll call this Web API, because that's fundamentally what we're changing here. And so that changes the name. Now we're going to change the function name to post to do. And what you'll see is there's a few different verbs that this is enabling. I'm going to take off the get verb and leave the post verb because we're going to do the post for the insert. Now the code that's structured for me is meant to echo a name back. So let's do this. I'm going to add a new class. And before anyone gets too excited, I'm going to do a demo trick and cut and paste some code. In a larger application, of course, we would have a class library and a data access layer so we could share this code. But to keep this streamlined, I'm going to go ahead and come into my API, grab the definition of the to-do item, and we'll take that into our function app and just paste that here. And then what we're going to do in the Web API is we're going to change the way this works. I'm going to remove some of the code that came with it. And I'm going to make this a to-do item. So this is to-do item. And when we deserialize it, we need to tell it that we're deserializing the type to-do item. And then we're going to do two things. The deserialization failed for whatever reason, so data is null. Or if we don't actually have a name for our task, that's going to be data.name, then we're going to return a bad result. We're basically telling the consumer of this API that this wasn't formatted correctly. We don't have what we need. Otherwise, I'm going to return a new no content result, which says everything's okay. I just don't have anything to return to you. So we're not saving to the database yet, but I'm going to set this breakpoint, and actually let's cancel this. This is actually launching my web projects, which I have configured in the solution. We want to go ahead and let that spin up right now. And then what we're going to do is actually launch the Functions app. So it's going to complain because I shut down that web API early. That's fine. We'll close this out. And we should come back into our IDE. So now let's take this and just point to the Function app and start that. Now what you're going to see is a powerful feature of Functions. This is going to launch a fully functional, see what I did there, Functions host locally on my machine. That's what you see coming up. This is the actual Functions host engine. I've got the full functionality locally so that I can debug and run my application. So it's launching that host for the functions, and it's going to look at my project to find the function endpoints that I defined. You can see it's reading the configuration file, and now it's pulled out this endpoint. So let's go ahead and take this endpoint and go into Postman, which will let me send a post request to the endpoint. So the first thing I'm going to do is just send it with an empty message. This should pop me into debug. And we can see if we step over, our data is null, so we would expect to get a bad content result, and that's what we got is a 400 bad request. So the next thing I'm going to do is go ahead and take this breakpoint off, and I'm going to give it something so that it can handle that. So we're going to set a content type to JSON, and in the body we're going to say tested new function. We'll go ahead and send that, and this time we get a 204 no content, so it successfully deserialized that. What I need to do now is go ahead and wire in my database. So I'm going to come back to this code, and I'm going to go into my tools and manage packages for the solution, and we're going to look for the entity framework for SQL Server. So I'm picking that, and this will of course go ahead and install the main entity framework as well. And I'm going to actually, this says version 201. I'm going to go to 200 because that's what I tested with, and we're not looking for surprises today. So this will tell me everything it's installing. I'll click OK. I'll sign my life away by clicking I accept. And this is going to add entity framework support. Now, for me to be able to talk to this, I need what's called a context, which is my connection to the database. So I'm going to go ahead and add a new item. I'm going to call this to do context. And then so you don't have to spend too much time watching me code, I'm going to go ahead and grab the code from over here. Let's make sure we're in our to-do context. Let's copy that. And we'll paste it in. Now the reason why I'm doing this is because I don't have a startup in my function app like I do in my web API app. The functions are essentially independent. So I need a different way to configure my connection string. So let me go ahead and pull in my usings. And then on configuring, I'm taking advantage of a hook in entity framework when it stands up the context to go out and again follow the same pattern I used before. We'll check locally and see if we have that, but overriding that will be anything in the environment. So I can test both locally and in the web. I'm going to go into my API, and I'm going to steal my connection string. This is just the one for the local server. And we'll go into local settings. It's the same format. This is a .NET Core app. So we'll save that there. And then we'll go into our web API. And we're going to change this a little bit. I'm going to make this an asynchronous method. So we'll add async. And of course, async returns tasks. We'll go ahead and pull that using statement in. And then if we have good data, which would be right here, I'm going to do a using var context equals new, and this is a to-do context. So that's this. And then this is going to expect a DB context options of type to-do context. So a little bit there, and then of course we'll need to add our using statements. Fortunately, it does that easily for me. All right, and then what I'm going to do is two things. First, I'm going to take the to-do items and add that data item asynchronously to the list, and then I'm going to wait for the main context to save those changes. And then if everything works fine for that, we'll return that no content. Let's go ahead and fire this one up. Make sure it runs locally. So that's building, and it's again going to launch the functions host for me. We'll let that spin up, and then what I'll show you really quickly is in our local database. I'm going to jump over here and execute. We have the same tasks that we've had for the duration of this presentation. Now I'm going to go into Postman, and I have this tested new function. So we'll send this, let it spin up, and we should get a 204 no content back. Now if we refresh the local database, we can see tested new function. So it's successfully added. So we're working locally. Let's go ahead and get this into the cloud. As I mentioned, I've shown you the experience for doing it from Visual Studio. I'm going to show you the experience from doing it from within the Azure portal, which I just conveniently closed, but that's okay. We'll open that back up. And from the portal, we're going to go into our resource group, which again is where we keep all our related assets together. And we're going to go ahead and create a new function app. Basically, I've got the resource group right here. It's going to refresh in just a second, and we'll go into that. And we'll click the add button that appears on top to let it know we're adding a resource to this group. And what we're going to search for is function app. So we'll do function app, click that, and go into create. Now we have to give the function app a unique name across Azure. So hopefully connect, if I can type connect to do fn is available. We'll wait for it to give us a check. It is. We're going to use our existing. Now here we can pick Windows or Linux. The Functions platform will run on Linux or Mac as well as Windows machines, so you can have that experience. I'm going to stick with Windows for now, but we could build this in a Linux environment and deploy it to Linux on Azure. We're going to create storage for this, and then I'm going to turn on something called Application Insights. That's going to give me rich telemetry and information about my application for free. We'll tell it to pin this to the dashboard and click Create. And that's going to go off and start spinning up a new function app. Now while it's doing that, I'm going to go back into the API that I had and go into the application settings because I'm going to borrow the connection string. I'm going to need that same connection string for my to-do app because it's inserting into the same database. So we'll come to this hidden for security value and we'll copy that, so now I have it conveniently available for when that function app is done creating. So we'll let that spin up. And then back in Visual Studio, we are going to take this function app and right click, go into that same publish dialog that you've seen, only this time we're going to do a select existing. And I'm going to just wait a second here for the app to finish deploying, but it should only take a few seconds, minutes maximum, for it to spin up this new host. So we can actually see the assets are being updated here. It's created some of the backing information for that. So it's just got this is the application insights that's going to collect that telemetry, and now it's going to create that function app host. We'll give it just another few seconds for that. And then we're going to deploy our new function to it. All right, so it's going to automatically jump me into the function app. I'm going to go ahead and take advantage of this opportunity to go into the application settings and add this new connection string. So we'll scroll down, add new connection string. We're going to do a to-do context and paste this in. We'll go back to the top and save that. So now the connection string is in place. Now we're ready to publish. I'm going to click the publish button, and this time the experience is going to let me navigate to the existing group that I have. So I've got the connect group and I've created this to-do function, so I'm going to select that and click OK. And now it's going to go through something that you should be familiar with by now. It's going to build this function app locally, push those assets out, and create a new endpoint for us. And once again, it'll recognize that this is a web-based trigger and should open up the web browser for us once this is published. If not, we've got the URL here conveniently that we can copy. So let's give this a second. It's adding directories, adding files, and we should see a publish in just a second. And now it's going to prompt me, because this is in preview, the code that I'm using, it's going to ask me to set a beta flag inside of the portal, which I'm going to say yes so that we know the setup. But that is all it takes to get that application out. So now if I refresh here, what I should see is this functions list expand to show the post to do function that I just added. So we'll give it a second to do that. And again, this has a little bit of startup once it's restarted the function, but we should see this pull in, and there we have our post to do function. I'll show you something neat about functions in the portal. Automatically, it's going to give me a little tab on the right-hand side that I can use to test the function. So what I'll do is post, and I'm going to make a task test from the portal. So we'll add that, and actually let me make sure I gave this a Yeah, that's not going to work. I need to give it a property of name, and we'll click run. And then in these logs, we can see function started, trigger function process a request, and function completed. Let me zoom in. I know those are a little small. So this is what we see with the logs, with the trigger. And I'm going to zoom this out for you. And then when we come back to our SQL Server Management Studio, we should be able to run our Azure database and see new task test from the portal. In fact, if I look at my running version of the application in the web, which we will change this to to-do web, which is the URL for our web application, I should see the new task appear in my web application. Now the next step I'm going to take, as this is pulling up, so we got the to-do list and we can see test from the portal, so that's done. We'll check it as complete. I'm going to come back into the portal itself, and it's going to give me a convenient way to copy the function endpoint. So right up here I've got get function URL. We're going to copy that, and I'll go back into Postman and paste that endpoint here. So this is now the Azure Web Endpoint for my function. And we're going to add a new task. This task will be test Azure function from Postman. We'll click send, and we should see a 204 no content, which is exactly what we wanted. And if we come back to our application and refresh, now we've got test Azure function from Postman. So our function is there, but the problem is right now our application is still talking to the old web API. I'm going to go ahead and kick off a process and then walk you through what I'm doing so that we can actually have a hybrid application that uses some of the new serverless functions and uses some of the web API platform as a service. I'm coming back into my resource group. I'm going to follow the same steps that I did to create the to-do function. I'm going to add. We'll do a search for a function app. We'll select that. Pick the option, pick create. And I'm going to give this a name of connect proxy. We'll be creative with that. Let's see if that's available. Connect-proxy. And it says that's good. And I'm looking at all the defaults. We're going to do this, since I'm on the West Coast, let's go ahead and make this West US. And this time I'm not going to turn on application insights because the only thing this application is going to do is proxy requests for me. So we'll click create and we'll let that spin up. Let's talk about what we're doing. So the next step is what I call integration. I want my web app to be able to talk to the new serverless function I created, but I don't want to have to rewrite it so that every single call has a different API endpoint. That's just too much overhead. So what I'm going to do is create a proxy. The proxy is going to redirect traffic for me, and I can point my web app to the proxy and then control the backend APIs from that proxy. So we're going to create this, we're going to test it, we're going to implement cross-origin resource sharing, update the URL, and deploy the web app. Let's take a look at what that looks like. As it's creating the function app in the portal, which I see it's still doing, I want to show you what the configuration for a proxy looks like. Now there is a UI for building proxies that you can do from the portal. I'll show you that in a second. But this is my basic configuration. What I've got is a proxy called collection redirect. Anything that comes into my proxy application that has this route of API to do, if it's using a get method, which would be get the whole list of to-do items, or if it's using options, which is what type of content can I use and can I cross-origin share, this is going to redirect it to our existing Platform as a Service Web API. That's the Connect To-Do API. The same thing when we go to a specific to-do item, we're going to take get, delete, and update, basically put, as well as options, and send that back to the Connect To-Do API. For the specific case of posting a new to-do item, so this is the API to-do route with a post method, we're going to send that to our new function endpoint. Let's take a look. So we've created the proxy. What I want to do is go into the proxies here and show you how we create a new proxy. So we'll call this new proxy. We'll give it a path, API, to do. We select which methods we're operating against that. Let's say put, and let's do a redirect to new site. Now what's really neat about proxies is I can also override the request and, for example, add new information to the header, as well as set up a response. So in the response, I might be able to mock a static JSON file, for example, and have a mock API while I'm designing the real API in code. So we'll click create for that. Now this is of course not the actual route I'm going to use. I wanted to show you how that's created in the portal. What we'll do is go to the advanced editor. Let me click on that. And the advanced editor is going to let me edit that proxy JSON directly. So we'll come over to this, which we've already built, copy that over, and once this loads, it's got to go through authentication. This is going to the management site for my function app inside the portal. So this lets me get access to logs and, among other things, deal with the files directly. So in this case, we're going to deal with the proxy file. We're going to wait for this to write. So this proxy app should be actually ready to go. So let's go ahead and take a look at how it's running. I'm going to go into an endpoint. And so what we had before was something like this: to do, actually connect, to do, API, API, to do. So that's what pulled back for us a list of the to-do items. The way this works with the proxy, I should be able to do the same thing and go to connect proxy, and that rule I had for doing a get against the collection should forward me and do the same thing. So you can see we're spinning, and again, as with all function apps, there's a little bit of startup time while it spins this up, but we should be able to see it in just a second, come back, and boom, we got the list. In fact, I should be able to go into a specific item and pull it back. So it's behaving the same way as before. What we want to do is test to make sure that the post functionality is now going to our function and not the old web API app. The way I'm going to do that is in the portal, I'm going to come back to my to-do function, which I can navigate to right here, and I'm going to open up the logs so I can see the live logs on that function. So we're in post to-do, the logs appear at the bottom. We're going to expand those. Give me just a second. So this up arrow will expand those. So now we're looking at the logs for the actual serverless function. If I go into Postman and I change this API, and this time we're going to send Azure function through proxy. That's what our task will be called. Let's click send. So it sends it out. We get the 204 no content. Let's take a look in the portal, and indeed we see that the serverless was triggered. So now that proxy endpoint will split off some requests to my platform as a service API and some requests to my new serverless. The last step that we need to take is just to update our web app to be aware of this. So I'm going to copy the link to the proxies. We'll paste this into the to-do web app. There's a section in the app that has a configuration for the API endpoint, so that's highlighted here. We'll go ahead and overwrite that with the new endpoint, which is the proxy. Save that, and then we're going to right-click publish this update. Let's do publish, and then while that's publishing, I need to take one more step. Now that the proxy is managing all these requests, the proxy itself is actually responsible for handling cross-origin resource sharing. So if I don't let the proxy know that it's okay to share resources across sites, those requests are going to fail. My application will fail. So what I do to remedy that is I go into the portal, and I'm going to now jump to my proxy. Let's refresh this, and we have our proxy. And there's a set of features that are available for function apps. We can access these in platform features. One of those features is cross-origin resource sharing. So we'll open that up, and that's going to give us a dialog of all the allowed domains. So we're going to add our connect to do web. Let's make sure my typing is good. Azure websites.net. and we'll save that. And now we've added that cross origin. So we'll come back to our build process. Again, it's going through the npm install, building the Angular side for that. So while it's doing that, I want to answer a question. This is, are there any limitations that you should be aware of in a serverless function HTTP request action versus a normal web API request? So to be clear, this is really what we call a trigger versus a web API. So web API has some very rich functionality around routing and allowing different verbs and different types of requests. There's similar functionality in the function trigger, but you specify it a different way. You have an attribute that gives the function name, tells you the type of that function. So you are going to deal with some things like authentication a little bit differently. It's not as simple as putting an authorized attribute on that. You have to implement the type of authentication you want. There's a built-in version that basically creates a secret key. So if you're secured behind SSL and you share that key, you can access the function. But if you wanted to do something, for example, like integrating with a third-party authentication, you would want to build that explicit functionality in the application. So it can take third-party packages. I'm actually going to show that in a minute, so you have that there, but it will behave a little bit differently because we're thinking of code that has different types of triggers. It could be a queue, it could be a timer, it could be a file dropped into storage, and so the paradigm of how we build this up is a little different. So now we're looking at the build for the web app, and we can see that it's about to publish it out. So I'm going to show you the publication using the proxy, but for the sake of time, I want to talk about the next step after we deploy this app, and that's application insights. So when I created that function, I checked a box, and I said that I was interested in having application insights for this. Application insights provides a ton of functionality out of the box. It's going to monitor for failures, for errors, for performance, and it's going to give me a heads-up dashboard. And I can see it actually launched my website here. So let me open this up, and there we go. It's pulled the full set of functions. We can actually check that we tested it through the proxy. We created the to-do function. We deployed it. But now let's add a new text, and that's add custom app insights. And this is going to go through our serverless function. We see that was added to the end, so that's working. So with these app insights, if I look inside of the portal and I go to the app insights for the function app, it's already collecting data for me out of the box. I didn't have to do anything to ask it to give me requests and performance. And when we look at this, we might be troubled at first because we're going to see some slow requests. And we'll let that pull up in a second. So we're seeing, here's a request, 2.7 seconds. Here's a little bit faster request. Here's the request endpoints. I can also go into this performance tab, and that tab is going to let me look at things like 50th percentile, 95th percentile. So I'm breaking down, I'm seeing the individual requests, and I'm seeing the spread. I'm less interested in how long it takes for that entire endpoint to be called. And I'm more interested in things like some of you, when you saw me creating the to-do context, you probably said, oh, he's looking at configuration settings and creating that connection every time. What is the overhead for that? Let's take a look at what it takes to instrument for custom dependencies. So we're going to add a package, create a client, store the telemetry, and view that in the portal. That's our last set of steps. Coming back to our web application, I'm going to go into my tools. I'm going to go back into my package manager. And this time I'm going to do a search for Application Insights Core. You can see that. And what we're looking for is a special version of Application Insights that's specifically for ASP.NET. This is ASP.NET Web API. We're almost there. There we go. Application Insights ASP.NET Core. So we're going to pick that for the to-do app. Come down here and install that. And what this is going to do is give me the SDK that I need to do specific instrumentation. So I'm going to accept that. Now that that's added back in, we'll go into our Web API. Now the cool thing is when I added Application Insights to the portal, it automatically created an environment variable that holds an instrumentation key. That's the unique way that I reference application insights. So I'm going to take this snippet of code, and that's going to give me a client that automatically talks to that instrumentation key. So we'll paste that into place, and of course we need to update our using so that it references the app insights in the environment. But now we have something to work with to interact with the application insights. So let's do something here. I'm going to start with the current date. I'm going to start a timer. It's in System, Diagnostics, Stopwatch, Start New. And then right inside here, this is where we spun up the context. So this is initially the overhead it takes to make a connection. We're going to do telemetry, track dependency. The dependency is SQL Connect. This is part of my context. We'll give it that start time. We'll give it how long it elapsed. And if we're here, we know it was successful, so I'm passing success as true. Then what I want to do is improve my logging and say about to insert to do with name. We'll give it data.name. That's actually a capital name. And then I'm going to reset the start date because I also want to measure how long it takes to insert the record. So we'll do that. We'll do timer restart. And then we're going to track the same type of dependency, but we're going to give it a different name so that we can distinguish it from the connection. So this is going to be SQL insert, and the command is going to be an insert command. And we'll go ahead and log info inserted. If I can type correctly, inserted with ID, and this time it's going to be data.id. All right, so we'll save that and publish that out. Right-click Publish, click Publish. And now we'll give it a minute to go out and actually restart that server. But we've added the new custom telemetry. The build should not take long. And our publishing failed. Let's see what we got. Identifier expected. I probably fat-fingered some code. We actually have a red bar here. Thankfully, the IDE is kind enough to point me to my errors. We're good to go there. Let's right-click Publish again. All right, this time I feel confident about success. Now, one thing to note is when the telemetry goes out, Application Insights buffers telemetry by default. This is to optimize the way the application runs, so it flushes it on a periodic basis. So what I'm going to do is once I know that the new function app is out there, I'm going to add a few items so that we can track the telemetry, and then I'm going to restart the server to force it to flush the data, and hopefully we'll have it come up quickly. I know we're nearing the end of the presentation. We are reading application settings, publish completed. So what we're going to do is now that the publish is out there, we can actually go out to our function app and monitor it again through the logs so that we make sure that our new code is there. Remember, I added the code that said I was inserting the to-do item and also bringing back the new ID. So I've enhanced my logging just by adding those two pieces of functionality. So we're going to refresh this, give it a second. We'll do this trick, spin it clockwise. There we go, post to do. And we'll expand that right here. Okay, so now we're monitoring. We'll come back to our homepage app, and now let's add an item. So let's just call this creatively 1 and give that a second to add. And we've got 1. Let's look at our app. And there we go, insert to do with name 1, ID 31, so we're good. Let's add a few more just so we collect some more statistics. So we'll do 2, 3, 4, and I've always wanted to end demo with flourish. So we'll add that task as well, make sure that's there. Okay, that's good. We'll see if I remember to check this. And now we're going to restart this application and go back into Application Insights. So I'm coming back to the top of my function app here. Going to restart to flush all of those stats. Come back into my group, jump into Application Insights. And then what we'll see on the main screen is we can go ahead and refresh those overall statistics that we see the timings and the requests coming in. That's what we're going to do in a second here. And now we can see there were a few more responses. Let's refresh a couple times. And let that just pull in some more functionality. Now I'm going to come down to the performance. This is the one that I indicated earlier that we just saw basically the to-do post endpoint. If we had multiple function endpoints, we'd see those. So now we've got a 920 millisecond, still pretty slow. So we want to dig into the details of why. Excuse me. So I'm going into my dependencies. This is the custom telemetry. I'm going to refresh this for a second. And if this doesn't come up right away, I want to go ahead and show you a final deck, and then we'll go out with this telemetry. It'll come in a second. So while I still have your attention, and before we look at this final step of the telemetry and application insights, hopefully today what I've shown you is that Azure is a feasible and viable and exciting target for lifting and shifting your legacy applications. And you don't just have to deal with virtual machines. You can take advantage of platform as a service, you can take advantage of serverless, and you can do it in a hybrid fashion through that migration. To learn more about what we talked about, I've got this link, aka MS-BYOA, Bring Your Own App, that'll take you to our Lift and Shift Architecture Center. I also have this free -FN that will allow you to start trying functions for free on your own. Again, my Twitter handle, @JeremyLickness. Feel free to DM me after this training if you have questions or follow-up, or contact me on my email, jeremy.lickness@microsoft.com. Let's jump back here and see if we have some updated statistics. We'll refresh. And now look at this. We've got our SQL Connect, which is 28 milliseconds, but if we drill into the details, there was one slow connection, which was probably the first one. The rest of these are 1 millisecond, so there's practically no overhead in opening that connection. For the insert, we've got a little bit of a different story, but we can see that those values follow a similar pattern. The first time a little bit slower, then we're around the 200 millisecond range, but that gives us rich information that tells us what part of our function is taking time so we can optimize for that. Again, my name is Jeremy Lickness, a cloud developer advocate here on the Azure team. Thank you for joining me for this training today.